Hello and welcome to my write-up of Ledger from Try Hack Me. So Ledger is a hard Active Directory machine. It first involves enumerating LDAP to find a domain object class user that has the description containing a password. From there, you can enumerate the domain, discover that a certificate template is vulnerable, and you can change the name in requested certificates. So you can craft a certificate from the domain controller and authenticate with a certificate of any user we like. So first I'm just going to start with nmap. So nmap-scv-vvv and -t5. What this means is -nmap-scv, so -sc scripts, -sv versions, -vvv, so verbose, and T5 standing for threads. T5 is the highest amount of threads you can have on the system. However, I would not recommend it. It can crash older hosts, very loud on the network, depending on what nmap scan you're doing, and you can miss results. However, in the CTF environment, I think it's fine, but just keep in mind it can miss ports. You can see here 44380 HTTP and HTTPS, RPC, DNS, SMB, RDP, and Kerberos. So standard domain controller ports. From here, the scan will reveal the host name, the domain name tryhackme.local. With the machine DNS name being labyrinth.tryhackme.local. Once this is given, there's not much more interesting information in the ports apart from, the standard domain ports, the standard domain controller ports, no vulnerable services. From here, any Active Directory environment, my first steps is to, in a CTF environment, my first steps are to find users. So I'll look through SMB, LDAP, RPC, try and leak any usernames. Worst comes to worst, can't find anything, I'll use I've got an enum for Linux that has some decent scripts that will try and enumerate users and give you more information about a domain controller. If I can't find users, I'll then target, web services, etc., fuzzing word lists. So let's start check for anonymous logon. Can we leak anything from RPC? RPC clients, user not specified, and such and such. No password, no username. So we can authenticate. We can authenticate with a null bind, meaning we don't need a password. This is a vulnerability in my opinion, but I don't think we can really do much. We can't enum dumb users. Entity status connection disconnected. I'm assuming potentially not allowed command because RPC client is, I think it's a penetration testing tool for RPC. And I'm assuming we can connect to RPC, except the actions we're trying to do results in some error. Well, obviously. From here, you may be able to RID cycle, cycle IDs. But that's another thing. Let's check SMB client. Can we connect by SMB? Yes, we can. It has SMB listing. You want that turned off by default in most cases. There's no point having the ability for an anonymous user to list the shares. Doesn't really do anything. You could accidentally leak important information or make the SMB server a target by having interesting file names. You want it turned off by default. There's all sorts of attacks that can slip by, such as NTL and relay attacks and phishing and all that. So yeah, we can connect to SMB anonymously. Nothing's in these shares. We're not allowed to view these shares. However, we can actually connect to them. The file permissions do not allow us to read anything, but we can connect. Next, we could try LDAP. So I like using netexec. Netexec does more of a abstraction from LDAP. It allows us to use LDAP functionality without the inherent complexity that I find LDAP search has, with all you need the two domain names, a CN and the other CN, and .com, local. It can get quite confusing when looking at and referring to notes. I just like NetExec because it's sleek, simple, lots of different functionalities. A great tool. We can see here we're just searching the LDAP, no username, no password, and we're querying for the object class of user, and we want to return the SAM account name. So it's just going to return all user accounts, the SAM account names of all user accounts. And let's see if we can authenticate. Yes, we can authenticate without a username or password. You can see here a full list of usernames. From here, we can download these usernames. So I have a neat one-liner that I like to use that allows me to put all these to a file using awk and t. So it'll just output all the found users to a file. And you can see here we do the -- users on NetExec to just print the users. So you can see here a whole bunch of domain users, tons and tons of domain users, and we got some text at the top. We can just remove or leave. It doesn't really matter. They're not valid passwords. I think it'll just get declined on the Kerberos. Whole bunch of characters. So once I have whole bunch of strings, whole bunch of user accounts. Once I have user accounts, couple of things come into mind. You know, whether they leak email addresses, you could try targeted phishing attacks. However, CTF environment definitely not going to be the play. But depending on the environment, before I start fuzzing passwords, I would like to get a look at, lockout passwords, how old the domain controller is. You could potentially crash all the domain controllers with massive password fuzzing, overload the logs, etc. In a high risk environment, e.g. hospital, government, you don't really want stuff to get knocked down. So always good to look at account lockouts. Don't want to lock out anyone's account. They're for alerting people, and don't want to alert any SOC. But CTF case doesn't matter. We can just fuzz for passwords, and in this case we'll test for not set pre-authentication. Requesting pre-authentication by default does not flag any events in Windows events, meaning that you can request for pre-authentication without alerting anything as many times as you want by default. But other solutions, external SOCs, other Windows security solutions may detect it. But if we request a user authentication that does not have pre-authentication enabled, it will trigger an alert. But if we request it on one that doesn't, it will not. So let's just test for pre-authentication. Not requiring pre-authentication, sorry. We'll use Impacket here. Get MP users. And we will supply the user file and the domain. Let's see here. And no password. So it's just going to go through. It's going to request to Kerberos and essentially request a TGT, not a. And if it's going to request a TGT. If it doesn't have, if it has pre-authentication disabled, we don't have to send any information, and it will give us the TGT encrypted with the user hash. From there, we can essentially decrypt. We can decrypt the hash by brute forcing. That's a good avenue. You can see here it's finding multiple ASREP hashes. It may take a second. After 2-3 minutes, this is completed. I think in total we found 5 user accounts that don't require pre-authentication. So we can just request an ASREP, which is a TGT encrypted with the user hash, and that's essentially what we have. We can try and crack this. So I've put all these in a word list. I've put all these in a file, hash.mpu. You can see here 5. So Phyllis McCoy, McQueen Garner, Isaiah Walker, Shirley Beard, Maxine Freeman. We can try and crack this with hashcat, just using the RockU word list. I think I forgot I had accidentally deleted the entire RockU word list on accident. I overwrote it. But these won't crack. However, an interesting thing to keep in mind is that it doesn't end there. So with accounts that don't require pre-authentication, you can request a TGS on their behalf. So you can ask the domain controller to access a service on their behalf. And since they don't require pre-authentication, you can ask it without needing to prove authentication. So you can request one on behalf of that user and get a TGS. I don't know exactly how it works. I think it's quite complex. But the attack is called, I'll get it up here. It's by Semperis, and it's quite interesting. So it's hard to describe, but essentially this covers how you can essentially Kerberos without pre-authentication. So you can Kerberos with users that don't require pre-authentication. And that's an interesting way of going about it. With this information, we can use in-packet get SPN users to get the TGSs encrypted with service account hashes. Let's look for some service accounts. So we'll just use netexec LDAP. Here we'll just remove all that, and we'll query for, I think the command is service principal names. Service So what this is going to do is essentially query LDAP and return all results where the service principal name equals anything. So effectively returning the SAM account name of any accounts that have the service principal name set. However, expected 2 arguments. That doesn't make much sense. Maybe full screen. Expected 2 arguments. They're joined. And you can see here we have the SAM account name of a SPN labyrinth. We'll add this to our word list. Game users, game user, and we'll add labyrinth here. And we'll use impact, get SPN users. Get SPN, get user SPN. You can see here we are getting the get users SPN, so no pre-authentication on the user Maxine Freeman. We're supplying it a user file, a list of users to test if they have if they're a service principal name. And DC host, we know there's only one, which is Labyrinth, and we're testing tryhackme.local, and Maxine Freeman was one of the users indicated that does not require pre-authentication. It may take a second. Let me just verify the IP address. The IP address is not the same. Yeah, you can see here it's returned the TGS of the Labyrinth machine account, I assume. We can try and crack this, however, no avail. Just keep in mind it's an interesting kind of thing to consider. Um, just when you're doing any Active Directory attacks. However, the solution to this machine lies in the description of LDAP. I find a lot of these machines kind of have a similar path, especially in Try Hack Me. Not necessarily a big fan. It's nothing new, you know, like it's just the description. Nothing interesting that much, but it's still cool. And it's definitely a thing that could happen in real life. Let me do object class equals user, and we want the description. So we're just querying LDAP for the description of object class users. You can see here a whole bunch of descriptions. Let's look for anything here. You can see the results here. So we have a password in the description for the Susanna McKnight and the Ivy Willis user. Every time I get a password, I chuck it in a word list and essentially fuzz all endpoints with the new passwords, any new users to see if anything connects. These are valid credentials on both users. We can connect via RDP, we can connect via SMB, everything. It's a valid domain credentials. From here, I did connect to the domain controller and tested for local privilege escalation, not any domain kind of sphere. After I hit some dead ends on there, I then tried any domain attacks. And that's when I, going through my checklist, stumbled upon a vulnerable certificate template that was vulnerable to the ESC1 or Escape 1, which is just like a class of vulnerabilities that essentially means you can request a certificate for a certain user. So we have the ability to alter the name on the certificate, and we can just authenticate via Kerberos and get the NTLM. With this certificate signed in any user. So we're going to use the tool Certify for this one. In order to install Certify, I just went to the GitHub, which is you just type up Certify GitHub, and it has some installation instructions. You can just install it from here, and you can install it via pip. So we're just going to use it here, Python. We're going to create a virtual environment so it doesn't conflict with any of our installations. We have to be root. Let's see if we can. And we can install it with pip install certify. However, this has already been installed. What we can do now is we can get certify to either queries RPC or LDAP to get certificate information. It can do it much like Bloodhound Python, for example. It doesn't actually have to be on the machine. So we're going to certify, find Susanna McKnight and password and the domain controller IP, and we want to search for vulnerable and stand it out. This is just going to search the machine for any vulnerable certificate templates. Sometimes a little buggy. No, it worked this time. I think it may just, there might be some sort of certificate authority template database of some sorts. You can see here it is found one certificate template that it thinks is vulnerable. We got all sorts of information such as the sort of certificate authority, DNS name, etc. Certificate authority is just in the tree of trust. The certificate authority is essentially a party that everyone trusts, and that party verifies public keys and private keys in public key infrastructure, and it's important in HTTPS and the web. But this, besides the point, this is just the certificate authority for the domain. So this handles the trust in the domain when dealing with public keys. If two users on the domain wanted to communicate via asymmetric encryption, it could use the certificate authority to verify each of the public keys. But you can see here, certificate templates server. So it's discovered this template as to be vulnerable. And you can see here the vulnerability is ESC1. So the enrollee can supply the name. And also what we want to pay attention to is not just the vulnerable template, but if we can actually enroll in it. So there's no point having a vulnerable template, trying to exploit a vulnerable template if it's only accessible by domain administrators. You can see here we can enroll as an authenticated user, which we are. So we can request this certificate as an authenticated user, and with this certificate we can abuse the vulnerability ESC1 to essentially ask for a certificate for another user. We can change the user tag, essentially. I think it's called something different, but we can change the user tag of the certificate to whatever we want. Let's exploit this with certipy. We can do certipy rec -u Susanna McKnight password and the certificate authority, which we identified before, the target domain name, the server auth, the template we want to change, and the UPN. This is the user we want to create a certificate on behalf of, and the domain controller IP. And it's requesting via RPC. You can see here we're using Bradley Ortiz instead of, an administrative user, which would be your first kind of try. And that was my first try. But however, when I was attempting this machine, it came up with that the account was couldn't be logged on because some security solution was monitoring, a suspicious time of date and time of day connection. So it would not allow me to successfully authenticate. You can see here it's errored out. Don't know why. Sometimes it can be a little buggy. And it works this time, yeah. And yeah, it's gotten a certificate and saved it to the Bradley Ortiz blah 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 PFX. I think PFX is the standard, what's it called? Extension for, private information. We can now use this certificate to request authentication via Kerberos and then get an NTLM. I don't know specifically how the NTLM is gained. I think it's slightly complex. And I got to do more research, but just essentially we can authenticate to Kerberos and gain an NTLM. We can do this also with certipy auth PFX. We want to supply another PFX file here. And it's trying to get the TGT for the user, so it's requesting an ASREP, and it's then attempting to decrypt that ASREP to gain the TGT, and that is what it's doing. If successful, it'll give us the TGT, allowing us for further authentication in the Kerberos flow of, authentication and authorization. It's given us a Ccache file, which is essentially just the TGT ticket. We don't care about this, although you could use it for anything. You could use it for WinRM. Don't know about RDP, SMB, etc. LDAP. And we got the NTLM. Actually, it's LM then NT. But yeah, NTLM hash. Essentially, in Active Directory environment, this is equivalent to a password. So, actually, we have gotten the wrong PFX file, which is for the administrator user. That was when I was originally doing this thing. we will have to get the PFX file for the Bradley Ortiz. Yeah, and we have the Bradley Ortiz NT hash. We can use this for authentication via, let's try WMI exec Windows Management Interface. If I'm not mistaken, it's essentially allows for like, I guess, like administration actions to be done on another computer, essentially via a port. Maybe over RPC. But yeah, we will use Impact for this. Hashes. Let's do here. Bradley Ortiz at therm.local. Let's see if this works. Cannot find string binding to connect. Maybe PS exec. Essentially what PS exec is doing is writing a malicious executable to the admin share and then running it. And that malicious executable is obviously some sort of a shell or bind shell. I haven't really looked, but yeah, we're Windows System 32. Sorry, we're NT Authority System. So we'll try. Who am I? NT Authority System. You can grab all the flags you want for this machine, but yeah, that's the end of it. I kind of like this machine. I feel like certificate abuse is maybe left out a little bit in, you know, CTFs, especially try hack the box. I've seen it a little more, but good machine. Allows for good enumeration. Kind of a rabbit hole with the ASREP hashes. You may spend a while cracking them, may get you a little confused going, oh, I always crack the ASREP hashes. But this time you can't, make you think about other options, etc. Has a lot of users, sort of simulates a real environment. But all in all, I think this was a good machine. Thank you guys for watching.